Okay, every polynomial is continuous. So first let's look at the definition of the sequential limit definition of continuity, which states for all sequences xn with the limit of xn as n approaches infinity is equal to c, then the limit as n approaches infinity of f of xn will be f of c. Okay, so for our proof here, let's fix c to be in the reals and let xn be a sequence with lim as n approaches infinity of xn is equal to c, which is our given condition. Okay, so let's define a polynomial f of x, which is just a standard polynomial here. We have a0 plus a1x plus a2x squared, and so on, up to a n x to the power of n, right? So there, hence, for f of c, this will become a0 plus a1c plus a2c squared plus the remaining parts of the polynomial up to an c to the power of n. Okay, so that's just from our defined initial conditions. So then this will just become a0 plus a1 from this fact here, that c is equal to the limit as n approaches infinity of xn. We can say that this is a1 lim n as approaches infinity of xn plus a2 lim n approaches infinity of xn squared plus the rest of the set up to an lim n approaches infinity of xn to the power of n. Okay, so now if we factorize out the limit, this will become a0 plus a1 xn plus a2 xn squared plus the rest of the set up to an xn squared. Okay, which, if we take this limit here, this will become what we have here, f of x. But x is just xn, so it becomes f of xn, right? Which is what we wanted. F of c is equal to limit of f of xn. Therefore, every polynomial is continuous.